So in order to do electron configurations for every atom, again, just as a review, we have a few orbitals. So these first two columns are our s orbital, and this first row is 1, 2, 3, 4, 5, 6, 7. So those numbers apply for s and p, which is this orbital over here. So this is p. Helium here belongs right there. And I'll show you what I mean by that in a second. So those are S and P, and again, those numbers apply to both. And then this here in the middle is D. And then D starts like one less. So even though it's in the same row as 4, it's actually going to be 3 and 4, 5, and 6. And then F is down here. This is the F orbital, and F is inserted right here. And if you notice, it starts at 5 for the D, but for F, it's actually going to start at 4. So it's 4 and 5. So you kind of count down one less. But if you want to mark that up on your periodic table, you should if you haven't already. So I'm going to go ahead and just do some electron configurations because I think showing you guys is sort of the easiest way to do it. So I'm just going to do something like short and sweet. I'm just going to do sodium. So sodium is right here. So the electron configuration for sodium. So I'm always going to start at the beginning. So that's hydrogen right here. So hydrogen is in energy level 1. It's in orbital s, and it's technically the first electron, but since I'm going past hydrogen to helium, I'm going to write 2. So the 2 there shows how many electrons I have. Because hydrogen has 1 proton, it also has 1 electron. Helium has 2 protons, so it also has 2 electrons. So again, this is the energy level, this is the orbital, and then these are the electrons that we went past. So now I'm going to energy level 2, right? Sodium's all the way in 3, so I have to continue on my periodic table. So lithium and beryllium are my next 2 electrons. So they're in 2s, and I have 2 of those. And then as I continue over, I actually hit the P block. It's still the same number, it's still 2, but now I have P and I have to count. 1, 2, 3, 4, 5, 6. So 6 electrons in P. So now I'm going to come down to here, and I'm at 3. And sodium is actually my first one. So it's 3s and then 1 because I stop at sodium. So that's my electron configuration for sodium. So I do it using my periodic table. So let's do one that's maybe a little further down, and let's include the d orbital. So let's do something like nickel. So again, it's actually the same as sodium all the way up to right here, but I'm going to start at the beginning again. I'm going to do it in a different color. Let's do it in green. Okay, so I'm here at hydrogen. That's 1, and helium is 2. So that's 1s2. And now I'm heading down to 2. So that's 1, 2, and 2s2. And then I'm going over to P. So 1, 2, 3, 4, 5, 6. So 2p6. And then I'm going down to 3, so I'm at 1, 2, so 3s2. And then I'm going over to aluminum, and I'm going to go 1, 2, 3, 4, 5, 6. So in 3p, I have 6. And I'm going down, because this is the row that I'm in nickel, right? So this is the row. So I'm going to have to go past potassium and calcium. They are in 4s, and I have 2 of them. And then as I go past calcium, I'm hitting my D block. So I'm in my D block, and remember that goes down a number. So this is D3, not D4. So 3D, and then I count 1, 2, 3, 4, 5, 6, 7, 8. So 3D8. That's my electron configuration for nickel. So that tells me where all of my electrons are located, right? 2 on the first energy level. I actually have 8 on my second energy level. I have 6 here and 2 here. On my third energy level, I actually have 8 with the 6 and the 2, but I have another one over here. So that's another 8. So I actually have 16 on the third. And then on the fourth energy level, I have 2. So that's what that information is telling us. If you run into one of the exceptions, I'll go ahead and show you one of the exceptions. So again, we're going to say generally this row here, where is it here? I'm going to use a different color actually. erase some of this so that we can see what I'm talking about. Okay, so remember this is the D block. So our exceptions fall right here in the chromium block, so that's 4 electrons, and then right here in the copper one, so that's 9 electrons. So notice it's like halfway away from being full, right? If there's 10 electrons here total, because I have 10 squares. So that's about halfway. It's 1 less than halfway is the chromium, and then 1 less than full is copper. So I'm going to go ahead and do chromium. So actually, I'm going to do the orbital notation for chromium just so that we can see that. So I'm going to start at 1s, and I have my hydrogen and my helium, so I have 2. So I'm going to show my electrons going different directions to make sure that I'm showing that they have different spins. Then I'm going down, right, following the periodic table to 2s. I have 1, 2, so again, going different directions. Then as I go over, I'm getting to 2p, and I have 1, 2, 3, 4, 5, 6 electrons there. So my p orbital has 3 orientations, so I'm going to put 3 lines for that, and I have 1, 2, 3, 4, 5, 6. Now I'm going to head down here to 3s. I'm just going to move down to another line, and I have 2 electrons there, 1, 2, and then I'm going over to 3p, so 1, 2, 3 again, because remember p has 3 orientations. And then I'm going to 4s, and I have 1, 2, and then I'm at 3d. So because d has 10 electrons, that means it has 5 orientations. Let me actually put it lower so I have more room. So 1, 2, 3, 4, 5. So again, this is 3d. So normally I would say I have 1, 2, 3, 4 electrons. So 1, 2, 3, 4 electrons. Now the exception that happens here, so remember we're in this column, the chromium column, and then this happens again in the copper column. We're just going to say generally. There's a couple other places it does happen, and there are some of those that are left out, but we're just going to say in general. If you guys move to AP, you'll probably do more specific stuff, but in general. So this happens to be kind of unstable, having the d orbital only half full, because it's on a lower energy level. So what it does is it actually pulls an electron from the higher energy level. So this electron actually gets pulled here. So if I were writing the orbital notation, this here would actually be replaced by 4s, oops, not below, 4s, and you would have 1 electron, and then you would have your 3d, and you'd have 1, 2, 3, 4, 5. So after 3p, that's what it would look like. Most of you are probably going to get to this point where you draw it just like this, and then it's going to be important to realize that you filled 4 of the 5 halfway, and that leaving that last one open is unstable, so you might have to erase at that point and fix it. But hopefully that's what you're recognizing. So if I was just going to do my electron configuration based off of my orbital diagram, I would start here, and I would say, okay, 1s2, and then just following it here, 2s2, 2p, and then I have 2, 4, 6, so 2p6, and then I have 3s2, and then 3p6, and then I have 4s1. Remember, I changed it, so there's just 1 here, 4s1, and 3d5. So that's my my electron configuration for chromium. If you guys need more examples, please let me know. I'm happy to do as many as you want me to do. Thanks.